All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So in this one, we're saying our frame shown is supporting a mass of 80 kilograms. Let's determine the forces acting on members A, B, C, and B, D, E, and on the pulley. So let's go ahead and go for it. First thing I would do here is anytime I'm given a mass, I know we have to convert that into a weight because we sum forces in statics, not masses. So let's go ahead and get that figured out. So our weight here, should be our mass times gravity. The mass was 80 times gravity, 9.81. This should be 785 newtons. With that known, we can go ahead and keep moving forward with everything. So let's figure out, my first step on a frame problem is to identify, do I have any two force members in here? Members with forces in only two locations. And on this one, we don't. A, B, C has forces at A, B, and C. Remember, B, D, E has forces at B, D, and E. Even the pulley would have things at C, a force way out the right edge from the cable, and a force up on the top, again from the cable. 3 locations for everything in there. So we can't really come in and do that first step. So we skip over it, and we come in and say, well, let's draw a free body diagram of the entire truss and see what we can find here. So we should look kind of like this. We have a horizontal member down at the bottom, and then we'll angle back up with that slanted member. At E, we have a pin, so I'm going to put in EY. I'll guess go straight up, EY. And I'm going to put in an EX. I'm going to guess goes to the left. At A, I should have an AY and an AX. AY, I'll guess goes up, and AX, I'm guessing goes to the right. I know that height here is 0.3 meters. 0.3 meters. Also, my width from A to B is 0.3 meters. 0.3 meters. From B to the center of my pulley is 0.7 meters. Let's draw that pulley in here. I know the center is where I measured that 0.7 at. And I can come in and say the radius of this was given as 0.1 meters. R equals 0.1 meters. And off the top of that, I have a cable that goes back and connects in to member BDE. Finally, at the far right edge of the pulley, I have my weight hanging down, which was what we just found, 785 newtons. 785 newtons. I don't need to include a tension in this cable because I could circle around the entire thing and not cut through that cable. If I did cut into it, I had to cut right back out to close out my circle. This gets internalized. I don't show that cable on my overall free body diagram. So what should we do here? Can I find all 4 of my unknowns? I have 3 equilibrium equations. I should be able to say I can't find 4 unknowns with 3 equations. That's mathematically impossible for us. Don't be the person that does that. But from there, can I find any of them? If I can't, then I should just move on and not worry about this step at all. That happens sometimes. For us, though, I could come in and say, well, if I sum moments at A, because E is directly in line with that, if E is right up above this, then summing moments at A is going to get rid of AX, AY, and EY. I can find EX. Or summing moments at E, I get rid of EX, EY, and AY. I can eliminate 3 of my unknowns in my moment. I can find an unknown then. So let's get what we can. If we can find anything, go ahead and find it. For this one, it's just going to be, we can get our 2 X pieces in here. So let's say with positive, going counterclockwise, I want to sum up my moments about point A. That's going to get me that my weight out here causes a clockwise rotation, EX causes a positive rotation. So let's come in and set that up for everything. My EX is 0.3 meters, so 0.3 EX. My weight will cause it clockwise, so minus. My force is 785. And my distance is 0.3 plus 0.7. That gets me to the center of the pulley. I need to add in the radius. So times 1.1 gets us to 0. If I solve for EX, I get a positive number out here, so I guess the right direction. My EX is 2,880 newtons. That's one of our external supports, so I just want to say magnitude and direction. I'll never change that direction around as I do statics, so just get magnitude and direction here. It is to the left. I guessed the right direction, and I know that because I'm getting a positive number when I solve my equation. That'd be one of my answers for everything. With EX known, I only have one unknown, the X direction left, so let's sum forces in the X. Summing forces in the X. I'll have AX to the right, minus EX, minus, we just found it, EX is 2880. Should get us to 0. Again, make your equation, even when it's a really easy one to solve out. Get the equation written to document your work, and then solve it. AX is 2880 newtons, and we got a positive here, so we have the right direction assumed. It's going to the right. That'd be our second answer in here. Again, it's a support reaction, overall one. It's what holds it to the wall. So I just want magnitude direction. I don't have to say on a specific member. But with those known, I have two unknowns left in the Y. I have one equilibrium equation left. Summing forces in the Y, though, isn't going to help me out for anything. They'll both be there. And there's no place I can sum moments and get rid of only one of these two unknowns. So I can't do anything else here. That happens, that's okay. When it happens, though, we just want to move on. So we can then explode our truss. There's three members I could draw a free body diagram of and try to analyze. I could look at A, B, C. I could look at B, D, E. Or I could take a look at the pulley. In general, if we know one of the forces on a pulley, it's going to be the easiest one to deal with. So let's draw a free body diagram of the pulley, and we'll start there. So we have our pin in the middle. On the far right edge, I have my tension coming straight down, 785. And on the top of the pulley, I have the cable coming off of that again. Tension in the cable is always the same for us, so this is still 785. And then I have my pin. I'm going to guess this goes up for CY and to the right for CX. And I can just sum forces in the X and the Y to get those two calculated out. Again, just show your work, but summing forces in the X, I'm going to get CX minus 785. CX minus 785 gets us to 0. I can solve for CX, and I'll get CX is also 785. But it's going to the right. We get a positive number here. I guessed the right direction. But this is an internal connection. It's connecting A, B, C to the pulley. So I want to say on which member? I'm just going to say on pulley to document that one. And that would be my next answer for this. 785 to the right on our pulley. Finally, on this one, I can come in just sum forces in the Y. Summing my forces in the Y direction. I get almost an identical equation. CY minus 785 equals 0, the weight hanging down. Or solving for CY, we get CY as 785 newtons going up on the pulley, which would be another answer for us. That's everything I can get with that pulley, though. But I'm getting some of my unknowns figured out. So where can I go next? Well, let's go to member ABC. Actually, let's go to member BDE. On BDE, I would have BX, BY. I'd have a tension at D. But it should be known. It's the same cable, has the same tension. And up at E, I have EX and EY. But I already found EX. So really, if I go to BDE, there's only three unknowns. BX, BY, EY. I can find all of them. So let's come in and try to tackle that. So we'll say on member... if we're drawing member BDE, it should just be a diagonal one for us. So we'll draw a diagonal line in here. At B, I can put in a BY. I'll guess that it goes up. And a BX. I'll guess that it goes to the right. If I go up to D, I get to my cable in here. I know it's in tension, so it still should be acting away from our member. In tension. And it's the same tension it was before, 785. It's the weight. Tension in a cable is always the same, 785. I also should be able to say if that cable goes straight, which it looks like it does, so we're going to go ahead and assume it does, then it starts out the radius up and goes straight over. This distance has to be the radius, 0.1 meters. The whole height of this from B to D to E is 0.3 meters, so this leftover is 0.2 meters. I also know the width of this is 0.3 meters. The last two things I need to get in here are EX and EY. I already assumed directions for them. Actually, no EX. We don't change our overall support reactions around. We keep them the exact same way. Realistically, we are finding them already on this member, so we're not moving to a new member. So I can put in EX. Going to the left in here, we already got that. It was 2880. 2880. And EY, I already assumed a direction on it. We want to make a consistent assumption then. Let's continue to show it in that same direction. EY. Going up. Three unknowns, BY, BX, EY, three equilibrium equations. I can solve this all out. So what do we want to do first? Why don't we sum forces in the x direction? If I sum my forces in the x direction, I'm going to get BX going to the right, BX, I get 785 to the right, plus 785, and I get 2880 going to the left, minus 2880 equals 0. Equals 0. We're solving for BX. I'm going to get a positive number here, so I guess the right direction on this. BX is 2,095. 2095 newtons. It's going to the right. B is a pin that connects two members together. Remember A, B, C, and B, D, E. So I want to include on which member? This is on B, D, E right now. So on B, D, E. To fully get an answer statement in there. And that would be my next answer. I'm down to two unknowns here. They're both in the Y. So let's do moments. I'm going to sum moments about point B. With positive going counterclockwise, let's sum up my moments about point B. That'll get me, my EY causes a clockwise rotation. So we'll put it in as negative 0.3 EY. Negative 0.3 EY. My 785 causes a clockwise rotation, so minus 785 force times distance, 0.1. The last thing, I have that 2880 from EX. It'll cause a counterclockwise rotation, so plus 2880 force times my distance is 0.3. 2880 times 0.3 gets us all the way to 0. Let's see if I can get that to look nice. 2880 times 0.3 equals 0. EY is my only unknown. I can solve this one for EY. I get a positive number, which means I have it correct here and back in my original free body diagram. EY is 2,620 newtons. This is an external connection. It's what we held up to the walls in our overall free body diagram. So I need to say direction. Upwards. I don't need to say on a specific member. Finally on this one, I just have BY left. I can sum forces in the Y to get it. So summing forces in the Y direction. I have EY going up. We just found that was 2620 plus BY equals 0. Which if I solve for BY, I get a negative. BY is negative 2620 newtons. That was negative when I assumed it was going up. We always want to report this as a positive and get the right direction. So we're going to come in and get a dashed arrow in here. So if I need to use BY again, I'll take that dashed form of it and then make it equal and opposite on a new free body diagram. But then we'll report it with the correct direction. BY is really a positive. We're getting rid of that negative, 2620 newtons. And our direction should be going down here, down. And we're working on member BDE for this one. On BDE. Because that's an internal connection for us, we're connecting two pieces together, we want to say on what member we're working with, because if that shows up on another one, we'd have a different direction. We got to make sure we're getting that right. But that's all but one of our unknowns left. All that we still have to do is find AY. I could come in and draw a free body diagram of ABC. That would work for us. I'd have to include AX and AY. I already know AX. AY I already assumed went up. I could show BX and BY. On ABC, I would make them equal and opposite. BX would go to the left, 2085, opposite, but the same magnitude. BY would go up, opposite, but have a magnitude of 2620 to be equal and opposite. And same thing all the way out at C. We change the direction on CX and CY to be equal and opposite when we move to a new member. That works for us, but really the easiest thing to do would be to say, I already drew a free body diagram that had AY on it. It's my only unknown left. We can come back over here now at the very end of this problem. We're coming back in and saying, let's just sum forces in the Y. Summing forces in the Y direction. I'd have AY going up. I would have EY going up. I know that's 2620 plus 2620. And I have the weight coming down. Minus 785 equals 0. Let's make sure that looks like a 0, not a 6. Equals 0. If I solve for AY, I get a negative here as well. AY is negative 1835 newtons. That negative means I guessed wrong way back at like one of the very first things I did in this problem. That's okay. It's really going down. We now recognize that. Let's report as a positive going down. AY is a positive 1835 newtons going straight down. And that'd be our final answer for our problem. A key thing here again, get the right direction, get what member you're on for those internal pieces, because it sets us up to be really successful as we move forward with everything. But hopefully this is a useful video for you. If it was, as always, hit those like and subscribe buttons. Stick around, watch more videos. Let's help you get an A with JJ.